Space, the final frontier, both beautiful and equally terrifying, expansing infinite miles and containing unknown horrors and unknown beauties. The eeriness of space has always interested me, so I decided to make a video on it and cover the iceberg and discover every crazy fact, conspiracy, or weird thing that's worth covering. So let's not waste any more time and get into the space iceberg. And actually, before we get into the video, consider subscribing. It's my goal to be at 100,000 subscribers by the end of the year, and I think we can do it. It's free and you can always change your mind, so why not join the community and subscribe? But now, since that's out of the way, let's get into the video. Alright, let's just dive straight into the iceberg, starting off with Tier 1 and the first entry being the 8 planets. Our solar system consists of 8 different planets. Closest to the Sun is Mercury, the smallest planet, followed by Venus, often called Earth's sister planet due to their similar size and composition. Earth, the third planet, being where we obviously live and it harboring life. Mars, the fourth planet, is famously known as the Red Planet because of its rusty surface. Beyond Mars are the gas giants, Jupiter, the largest planet with a prominent ring system, and Saturn, known for its distinct and extensive rings. Further out are the ice giants, Uranus and Neptune. Uranus is distinctive for its unique tilt, appearing to roll on its side as it orbits the Sun, while Neptune, the farthest known planet, exhibits a deep blue hue and powerful winds. Following the International Astronomical Union's definition, these 8 celestial bodies are recognized as the planets in our solar system, excluding Pluto, which was reclassified as a dwarf planet in 2006. But don't worry, we'll go back to Pluto and the controversy surrounding that later down in the iceberg. The Sun. The Sun is the center of our solar system and obviously what shines bright in the sky every single day. A massive luminous sphere of hot plasma primarily composed of hydrogen and helium. It's by far the most significant object providing light and heat essential for life on Earth. It's located at the heart of our planetary system, and its gravitational pull holds all of the planets, moons, asteroids, and other objects in orbit around it. This enormous star is about 4.6 billion years old and is in its stage of its life cycle, where nuclear fusion reactions in its core produce energy. These reactions generate intense heat and light that radiates into space, influencing the climate and conditions on all planets within its gravitational influence. The Sun's surface temperature is approximately 5,500 degrees Celsius, and for most Americans, 9,932 degrees Fahrenheit, while its core temperature exceeds millions of degrees Celsius due to the incredibly high-pressure nuclear fusion occurring there. Additionally, the Sun's energy drives weather patterns, ocean currents, and the overall climate on Earth, making it one of the most important things in all of existence because it obviously makes life possible. There is no air in space. Pretty obvious, but let's cover it anyways. There is no air in space. In the vast expanse of space, there exists a near total absence of matter, including air. Between celestial bodies, such as planets and moons, space is essentially a vacuum, devoid of an atmosphere. Earth's atmosphere gradually thins out and dissipates as you move away from the planet, eventually merging into the vacuum of space. This lack of atmosphere means that there's no air to support life as we know it. And, however, the absence of air in space has several unique implications. In the vacuum of space, there is no air pressure. On Earth, we're accustomed to the pressure exerted by the atmosphere, and in space, this lack of pressure can cause bodily fluids to vaporize, hence the need for astronauts to wear pressurized suits to survive in space. Another consequence of the lack of air is the absence of sound, which we'll cover later, but I'll just give a quick brief over right now. Sound waves require a medium, such as air, to travel through. In space, where there's no air, sound cannot propagate. Thus, the common portrayal of silence in space scenes in movies or TV shows reflects this reality. Though within spacecraft, astronauts can hear sounds since they're filled with air inside the spacesuits. Astronauts operating in space must rely on life support systems to provide them an oxygen to breathe, as well as protection from the extreme temperatures and radiation prevalent in space. Although certain celestial bodies, like planets or moons, may have their own atmosphere composed of different gases, the vast vacuum between these bodies remains void of any substantial air or matter. The moon being obviously the second big thing floating out in the sky other than the sun, and so the moon, Earth's natural satellite, orbits our planet at an average distance of approximately 2,038,855 miles away from Earth. It's the fifth largest moon in our solar system and has a significant influence on Earth's natural processes. As it orbits Earth, the moon goes through different phases due to its varying angles at which sunlight strikes its surface. These phases create the familiar cycle of the full moon, new moon, quarter moons, and more. The lunar surface is characterized by various different features, including Maria, which is dark, flat plains formed by ancient volcanic eruptions, as well as craters resulting from impacts with space debris. The moon also possesses mountains, valleys, and highlands. One striking aspect is its lack of atmosphere, leading to extreme temperature fluctuations, from scorching heat in sunlight to freezing cold in the shadows, with gravity about 1/6 that of Earth. And that's why they can jump so high. And the moon offers a distinct experience for astronauts. During manned missions, astronauts on the lunar surface can leap higher and move with less weight compared to their experiences on Earth. And the moon's gravitational pull affects Earth's tides and helps stabilize our planet's axial tilt, which is crucial for maintaining our climate and seasons. Human exploration on the moon began with the historic Apollo 11 mission in 1969, but we will get to that later on in the video because that's a pretty big topic by itself. And other missions have further understanding of the moon's geology and history, collecting valuable data and samples. The moon remains an object of fascination and scientific study, offering insight into the history and formation of this weird planet that sits in our sky. The search for life. The search for life beyond Earth encompasses various methods. Scientists study extramorphals to identify potential habitable environments on other planets or moons. They focus on places where liquid water might exist, like Mars or Europa. Mars missions seek evidence of past or present microbial life, while astronauts hunt for exoplanets in habitable zones. Additionally, SETI scans the sky for artificial signals, aiming to detect intelligent communication. While no definitive evidence has emerged, these ongoing efforts bring us closer to answering the questions: are we alone in the universe? But we'll get more onto the aliens and other stuff like that further down in the iceberg. Satellite TV. Satellite TV refers to television programming delivered via communication satellites. This technology involves transmitting television signals from a broadcasting station to satellite in orbit, which then relays these signals back to Earth. Satellite TV shows allow viewers to access a wide range of channels, including local and international stations, offering diverse content such as movies, sports, news, and entertainment. To receive satellite TV, a user needs a satellite dish installed at their location, typically on their property. Neil Armstrong was an American astronaut and on the first person to walk on the moon. On July 20th, 1969, during the Apollo 11 mission, Armstrong took a historic step onto the lunar surface and uttered the famous words, "That's one small step for man and one giant leap for mankind." Born on August 5, 1930 in Waukesha, Ohio, Armstrong developed an early interest in aviation. He served as a U.S. Navy pilot and later joined NASA in 1962. His extraordinary piloting skills, coupled with his engineering knowledge, made him an essential part of the space program. Armstrong's historic moon landing was a culmination of years of scientific advancement and collective efforts of the NASA team, and his steps on the lunar surface marked a monumental achievement in human history, demonstrating American technological prowess in the space race and fulfilling President John F. Kennedy's goal of landing humans on the moon before the end of the 1960s. Following his mission to the moon, Armstrong continued to work in various roles, including teaching aerospace engineering and serving on various boards and committees. He passed away on August 25, 2012, leaving behind a legacy of courage, exploration, and inspiration as the first person to set foot on the moon. Although, what do you think? Do you think he really went to the moon? Or he really didn't? One of my favorite conspiracy theories, but that's a whole rabbit hole for maybe a whole different video. But let me know what you think about that conspiracy in the comments below. Killer asteroids, also known as potentially hazardous objects, otherwise known as PHOs, are celestial bodies such as asteroids or comets that have the potential to collide with Earth with devastating consequences. These objects range in size, and larger ones could cause catastrophic effects upon impact due to their kinetic energy. An impact from a substantial asteroid or comet could trigger regional or global devastation, leading to mass extinctions and significant environmental damage. Efforts to detect and monitor these near-Earth objects are ongoing. Several observatories and space agencies around the world track and catalog these objects, aiming to predict these trajectories and assess the potential risk they pose to our planet. Organizations like NASA are dedicated to identifying and characterizing potentially hazardous asteroids to mitigate any potential threats. Various strategies have been proposed to address the potential impact of killer asteroids. These include developing early warning systems, devising methods to alter their trajectories, and exploring means to mitigate the damage caused by their potential impact. Alright, now on to Tier 2, starting off with the Space Shuttle, a pioneering and iconic spacecraft developed and operated by NASA, served as a versatile transportation system for space missions, consisting of the orbiter, solid rocket boosters, and external tank. The Space Shuttle enabled astronauts and cargo to be ferried to and from space. The orbiter, the primary component that carried crew and payload, safely returned to Earth after missions, distinguishing it as a reusable spacecraft. This program, active from 1981 to 2011, facilitated an array of missions including satellite deployment, scientific research, construction and maintenance of the International Space Station, and as well as servicing the Hubble Space Telescope. However, due to the safety concerns, high operational costs, and aging hardware, the Space Shuttle program was retired. Yuri Gagarin was a Soviet cosmonaut and the first human to journey into outer space. On April 12, 1961, aboard the Voskhod 1 spacecraft, Gagarin made history by completing a single orbit around the Earth, marking a significant milestone in space exploration. Born on March 9, 1934 in the village of Klushino, Russia, Gagarin's spacecraft lasted around 108 minutes. His spacecraft orbited the Earth at the altitude between 143 and 203 miles during the flight. He famously radioed back the phrase "Poyakali," or "Let's go," to ground control, signifying the beginning of an era of human space travel. Gagarin's successful mission made him an international hero and a symbol of Soviet space achievements during the space race, a period of competition between the United States and the Soviet Union in space exploration. He received numerous awards and honors, becoming a prominent figure in both the Soviet Union and globally. Tragically, Gagarin died on March 27, 1968, during a routine training flight. His legacy as the first human in space remains a pivotal moment in the history of space exploration and just history in general. The Big Bang Theory stands as the prevailing explanation for the origins and development of the universe. Approximately 13.8 billion years ago, it suggests that the cosmos began as an extremely hot and dense singularity before expanding rapidly. This expansion led to the formation of matter and energy and the eventual creation of galaxies, stars, and the structures observed in today's universe. Evidence supporting this theory includes the presence of a cosmic microwave for background radiation, a pervasive, uniform remnant of the universe's early stages. The theory continues to serve as a foundational framework in cosmology, shedding light on the universe's evolution, even though questions about the initial singularity or what might have preceded it remain areas of ongoing scientific inquiry and exploration. Space has no sound. In the vast vacuum of space, sound, as we typically understand it, cannot be transmitted. Sound waves require a medium, like air, water, or solids, to travel and be perceived by our ears. In the absence of a medium, such as a near-perfect vacuum of space, there's no air or matter to carry sound waves, resulting in silence. While space itself is devoid of sound, space missions or videos often portray sounds for the benefit of viewers or for technical purposes. For instance, sound effects might be added for documentaries, films, or simulations to represent what scientists theorize such a phenomena might sound like if they were audible. However, within spacecraft, there is air and thus sound. Astronauts can communicate and hear sounds within the confined, controlled environments of their spacecraft. as they are filled with air or other gases necessary for life support. But in the vastness of space between celestial bodies, there's no medium for sound to travel, creating a notably silent environment. Pluto is a planet. We're going back to our first entry in the iceberg and how I said there's kind of a controversy surrounding, is Pluto a planet or is it not? And let's get into it. The status of Pluto as a planet has been a subject of debate and controversy in the field of astronomy. For many years, Pluto has considered the ninth planet in our solar system after its discovery in 1930. However, in 2006, the International Astronomical Union redefined the criteria for classifying celestial bodies and established three essential conditions for an object to be considered a planet. Number 1, it must orbit the sun. Number 2, it must be spherical in shape due to its gravity. Number 3, it must have cleared its orbit or of other degrees in objects. And Pluto meets this first two criteria as it orbits the sun and is spherical. However, it does not meet the third criterion, as it shares its orbit with other objects in the Kuiper belt, a region beyond Neptune populated by numerous icy bodies. Consequently, the IAU reclassified Pluto as a dwarf planet in 2006. This decision causes significant change in the understanding of what defines a planet, leading to Pluto no longer being considered one of the 8 recognized planets in our solar system. Despite this reclassification, the debate and sentiments surrounding Pluto's status as a planet persist among some scientists, educators, and the public, with ongoing discussions about the criteria and classification of planets in our solar system. The ISS, the International Space Station, stands as a collaborative endeavor among various space agencies worldwide, including NASA, Roscosmos, ESA, JAXA, and CSA. It orbits the Earth at an average altitude of about 250 miles, moving at a speed about 17,500 miles per hour. Each orbit around the Earth takes approximately 90 minutes, allowing the crew to witness 16 sunrises and 16 sunsets each day, functioning as a multidisciplinary research laboratory. The ISS conducts scientific experiments in diverse fields like biology, physics, astronomy, and material science. The data it collects provides valuable insights into human physiology in space, technological advancements, and Earth-related studies, among other subjects. This ongoing research aims to benefit life on Earth and inform future space missions. The ISS symbolizes international cooperation with modules and components contributed by different nations. Constellations, formations of stars in the night sky that create recognizable shapes or patterns, have been observed and utilized by various cultures for thousands of years, serving as tools for navigation, storytelling, and time tracking. These patterns offer a sense of familiarity and orientation in the vastness of the night sky, named after mythological figures, animals, objects, or characters from ancient tales. Constellations include recognizable formations such as Orion, Ursa Major, which contains the Big Dipper, and Leo. Traditionally, the International Astronomical Union, otherwise known as the IAU, recognized 88 different constellations, dividing the celestial sphere to cover the entire sky, offering distinct sections. While the stars within a constellation may seem close together when viewed from Earth, they might be a vast distance from each other in actual space. Their apparent proximity is the result of Earth's line of sight and perspective. Constellations historically played a crucial role in navigation, aiding travelers and sailors by providing orientation. And in modern astronomy, these groupings continue to serve as markers to pinpoint and locate positions in the night sky, aiding astronomers and stargazers in their observations and studies. These formations carry both cultural and scientific significance, weaving a rich tapestry of traditional and understanding across various different civilizations and historical periods. Elon Musk, and this is a pretty broad one to be honest, and it's just, Elon Musk, most people know him, and he's done a lot, and he's done stuff for cars, for space, for other sort of endeavors, but I'll just cover Elon Musk as a whole, because why not? Then you'd know who Elon Musk is. Elon Musk, the renowned entrepreneur and business magnate, has made significant strides in various cutting-edge technological sectors. Born on June 28, 1971 in Pretoria, South Africa, Musk has been a driving force in several transformative ventures. Co-founding Tesla, he aims to revolutionize the automotive industry by promoting electric vehicles and substantial energy solutions. Tesla's electric cars and energy storage products have played a crucial role in advancing the global shift towards renewable energy. In addition to Tesla, Musk founded SpaceX, which I think this is actually referring to because this is a space iceberg and SpaceX. But SpaceX is a company focused on reducing space transportation costs and enabling human settlement on Mars. SpaceX has achieved numerous milestones, such as sending cargo to the International Space Station and developing spacecraft for crewed missions. Musk's vision also extends to innovative projects like Neuralink, exploring brain-computer interface technology, in The Boring Company, which seeks to address urban transportation challenges through tunnel systems and high-speed transit. Elon Musk's ambitious pursuits and groundbreaking initiatives have left a lasting impact on diverse sectors, including automotive, aerospace, energy, and technology. The sun will die someday. And this entry seems more fitting from an existential crisis iceberg, but this is space and the sun will die someday, so let's just cover it. Indeed, the sun, like any other star, has a finite lifespan. As a main sequence star, the sun's energy is produced through nuclear fusion in its core, primarily converting hydrogen into helium. Over time, the sun steadily burns its hydrogen fuel and will eventually exhaust its primary fuel source. As the sun ages, it will undergo significant changes. In about 5 billion years, it will enter a phase known as a red giant phase. During this stage, the sun will expand and become many times larger than its current size. It will engulf and destroy the inner planets, including Earth. So everything we've ever done and ever will do will technically just be burned up one day. Unless we move to a different galaxy, of course, but that's where kind of the existential crisis comes, because does everything we do not matter because it will just be burned up? But I'll leave that depressing stuff off to the side and maybe for a different video. This remnant core will significantly denser than the current sun, but it will no longer produce nuclear fusion, leading to a slow cooling and fading process over billions of years. While the sun's life cycle extends far beyond the human timescale, its eventual fate as a dwarf white marks the conclusion of its active life as a main sequence star. This natural life cycle of stars, including our sun, is an integral part of the universe's cosmic evolution. Curiosity rover. The Curiosity rover, part of NASA's Mars Science Laboratory mission, embarked on its journey to Mars, landing in Gale Crater on August 6, 2012, after its launch in November 2011. This sophisticated robotic vehicle stands out as a significant advancement in Martian exploration. Equipped with a suite of scientific instruments designed to study the red planet's geological features and its potential habitability, weighing approximately 2,000 pounds, the rover is larger than its predecessors and hosts various tools, including cameras, a rock drill, and laser for chemical analysis, an array of scientific instruments for comprehensive experimentation. Initially planned for a 2-year mission, the Curiosity rover has far surpassed its expected operational lifetime and continues to operate effectively, making substantial discoveries. Among its significant findings are indications of an ancient stream bed, meaning that there was someday water on the Mars, which just blows me away because it's kind of crazy that water was there one day. Also excites me to see what we're going to find in the future. The presence of organic molecules and evidence supporting the potential habitability of past Martian environments. This technological marvel, showcasing advancements in navigation, scientific analysis, and communication capabilities, continues to be a pivotal asset in NASA's extensive exploration and scientific investigations on the Martian surface. We choose to go to the moon. "We choose to go to the moon" is a famous line from President John F. Kennedy's speech derived on September 12, 1962, at Rice University in Houston, Texas. In this pivotal address, Kennedy passionately outlined the vision and commitment of the United States to undertake the monumental challenge of landing a man on the moon and returning him safely to Earth within the decade. The speech was a critical moment in the space race in a larger context of the Cold War between the United States and the Soviet Union. Kennedy's announcements rallied national support and sparked the Apollo program, ultimately leading to the successful lunar landing of Apollo 11 on July 20, 1969. Kennedy's vision and determination became a symbol of American ambition and technological prowess, demonstrating the nation's capacity for innovation and exploration. The Apollo 11 mission, culminating in astronaut Neil Armstrong's historic first steps on the lunar surface, remains a milestone in human history. Alright, now on to Tier 3, starting off with Sputnik. Sputnik, which means satellite in Russian, was the world's first artificial satellite, launched by the Soviet Union on October 4, 1957. Sputnik marked a significant milestone in human history by becoming the first human-made object to orbit the Earth. Sputnik was a small, spherical satellite equipped with radio transmitters, emitting a distinctive beeping sound that could be heard on Earth. The launch of this site marked the beginning of the outer space age and initiated the space race between the United States and the Soviet Union during the Cold War. This event had considerable implications, triggering global awe and concern over the Soviet Union's technological advancements and led the United States to accelerate its space exploration efforts. Simulation hypothesis is a thought-provoking concept that suggests our reality might be a computer-generated simulation rather than an objective physical existence. It proposes that everything we perceive, including the universe, our consciousness, and experiences, could be akin to a highly advanced computer simulation. Advocates of this idea draw parallels between our increasing capabilities in computer science and the potential for advanced civilizations to create a detailed and realistic simulation of an entire universe. Proponents of the hypothesis point to anomalies or limitations in our understanding of reality as potential indicators of a simulated existence. They often reference unexplained phenomena in quantum physics or cosmology as possible evidence of glitches or artifacts within the supposed simulation. Exoplanets, or extrasolar planets, are celestial bodies outside our solar system orbiting stars other than the Sun. These distant worlds are a subject of intense interest and study in astronomy, offering insights into the diversity and prevalence of planets in the cosmos. Detecting exoplanets involves various different methods, including observing the dimming of a star's light as a planet passes in front of it, detecting the star's wobble due to orbiting planet's gravitational pull, direct imaging, or gravitational microlensing. These exoplanets exhibit vast diversity in terms of size, composition, and orbital characteristics. Some are rocky and comparable in size to Earth, while others are much larger, potentially being gas giants or even free-floating rogue planets. Understanding these variations is crucial in unraveling the complex nature of planetary systems beyond our own. Of particular interest are exoplanets located within the habitable zone of their host stars. The habitable zone is a region where conditions may support the existence of a liquid water on the planet's surface, considered a key factor in assessing a planet's potential to harbor life. The study and discovery of exoplanets continue to expand rapidly, with thousands confirmed and numerous potential candidates identified. These ongoing investigations broaden our understanding of planetary formation, evolution, and the prospect of finding habitable worlds beyond our own solar systems. Uranus is sideways. Uranus is often referred to as a sideways planet due to its unique tilt. Unlike most other planets in our solar system, which have relatively upright rotations as they orbit the Sun, Uranus spins on its side. Its axis of rotation is nearly parallel to the plane of its orbit around the Sun. This extreme tilt causes the planet to appear as if it's rolling on its side as it orbits the Sun. In essence, Uranus essentially rotates on its side, with its pole nearly in the plane of its orbit. This peculiarity results in extreme seasonal variations on Uranus, where each pole experiences about 42 years of continuous sunlight, followed by 42 years of darkness during its orbit around the Sun. The cause of Uranus's extreme axial tilt remains a subject of scientific investigation and different theories, possibly resulting from a collision with a massive object early in the planet's history. The speed of light, and I'm not sure what this is really referring to, whether it's just saying how fast speed goes, but I'll just try to cover it broadly. And the speed of light in a vacuum, denoted by c, is approximately 2,999,792 kilometers per second, or about 186,282 miles per second. In scientific notation, it is roughly 3 2 times the 10th to the 8th power meters per second. This speed, recognized as a fundamental constant in physics, is the maximum speed at which all energy, matter, and information can travel in the universe. According to Einstein's theory of relativity, light, as electromagnetic radiation, travels at its fixed speed in a vacuum, and nothing with mass can reach or exceed it. The speed of light is a cornerstone in physics, forming the basis of various theories and concepts, such as the relationship between energy and mass, which is the famous E=mc² equation, and our understanding of the structure of space and time. This constant speed is essential in shaping our understanding of the universe and plays a fundamental role in numerous scientific disciplines. Age of the universe. The estimation of the age of the universe, currently around 3.8 billion years old, is derived from various observations and scientific models, primarily based on the concept of the Big Bang Theory, which we covered earlier. And the age determination involves studying the expansion rate of the universe, the cosmic microwave background radiation, and the distribution and behaviors of galaxies. Black holes. Black holes are enigmatic cosmic entities characterized by their incredibly strong gravitational pull, so intense that even light cannot escape from their vicinity, due to an area called the event horizon. They form from the collapsed cores of massive stars, where the force of gravity overwhelms the internal pressure, leading to an infinitely dense singularity at the center. Black holes come in various sizes, with stellar, supermassive, and intermediate black holes being the primary classifications. Their presence is often inferred through the effect that they have on nearby objects, as they bend the path of light and matter due to their immense gravitational force. While their direct observation is challenging, scientists study them through the observation of their impact on surrounding matter, furthering our understanding of the laws of physics under extreme conditions and the dynamics of the universe. Chris Hadfield, a retired Canadian astronaut and former Royal Canadian Air Force fighter pilot, is widely celebrated for his significant contributions to space exploration. Throughout his illustrious career, Hadfield embarked on 3 space missions, notably serving as the mission specialist for STS-74 in 1995 and STS-100 in 2001. However, his most prominent role came as the commander of the International Space Station during Expedition 35 in 2013. As the first Canadian to command the ISS, Hadfield made a considerable impact on space exploration. During his time aboard the ISS, Hadfield became known for his engaging social media presence throughout captivating photos, videos, and insightful commentary. He offered a unique and accessible perspective on life in space, connecting with the public and sparking interest in the wonders of space. His musical talents also shone through as he played the guitar and sang while in orbit, recording a rendition of David Bowie's Space Oddity, which garnered immense attention and went viral. Following his retirement from the Canadian Space Agency, Hadfield ventured into public speaking and writing. His books, including An Astronaut's Guide to Life on Earth and You Are Here Around the World in 92 Minutes, provide personal insights into space travel and offer valuable life lessons. Beyond his literary pursuits, Hadfield remains a passionate advocate for space exploration, frequently engaging in public events, educational programs, and media appearances, and to inspire and educate audiences about the significance of space and science. Venus backwards. Venus, spelled backwards, is Sun V. And that's all I have for this one. I don't really know what else to do for this unless I'm missing something, but Sun V, and V being the Roman numeral, I'm pretty sure, for 5. So, Sun 5, maybe? I don't know. Let me know if you know anything more about this in the comments below. Michael Collins, a distinguished American astronaut, made a big mark on space exploration on the command module pilot for the historic Apollo 11 mission in 1969. During this groundbreaking mission, while Neil Armstrong and Buzz Aldrin descended to the lunar surface, Collins skillfully piloted the command module, orbiting the moon alone in the spacecraft named Columbia. His crucial role involved overseeing the mission's success by ensuring communication with Earth, monitoring systems, and waiting for the return of his fellow astronauts after their iconic moonwalk, which marked the first steps on the lunar surface. Collins' responsibilities as the command module pilot were vital for the safe return of the crew to Earth, underscoring his essential contribution to the success of the mission. Before joining NASA, Collins had a notable career in the United States Air Force, where he served as a test pilot. He became an astronaut in 1963 and flew into space twice. After the Apollo 11 mission, he continued working for NASA in various capacities until his retirement in 1970. Subsequently, Collins delved into writing, notably penning a memoir titled Carrying the Fire, which offered an intimate and insightful portrayal of his experiences in the space program. His book remains highly regarded for its personal accounts and reflections on his journey through the Apollo missions and the world of space exploration. Michael Collins' significant role in Apollo 11 and his subsequent contributions to public understanding of space exploration through his writings have cemented his legacy as an esteemed astronaut and a key figure in the history of space exploration. The moon is drifting away. Yeah, the moon is actually gradually moving away from Earth. This phenomenon is known as lunar recession. The moon's distance from the Earth is increasing at a rate of about 1.5 inches per year. This movement is caused by tidal forces between the Earth and the moon. Tidal forces are a result of gravitational interactions. As the moon orbits the Earth, its gravitational pull causes the Earth's oceans to bulge, creating tides. Simultaneously, the Earth's gravity exerts a force onto the moon. Over time, this interaction causes a transfer of energy between the Earth and the moon. As a consequence of these tidal forces, the Earth's rotation is gradually slowing down while the moon's orbit is expanding. This process leads to the moon moving away from Earth. It's estimated that around 1.4 billion years ago, the average distance between the Earth and the moon was significantly closer than it was today. However, the rate at which the moon is moving away from the Earth is not constant and can be affected by different factors, including changes in the Earth's rotation, interactions with other celestial bodies, and more complex gravitational dynamics. Nonetheless, in the present era, the moon's recession from the Earth is a gradual but ongoing process. Center of the galaxy. At the center of most, if not all, galaxies lies a supermassive black hole. These cosmic entities are incredibly dense and possess immense power. And yeah, that's all I have. Satellites orbit Earth. Satellites orbiting the Earth serve a multitude of purposes, each type designed for specific functions and placed in distinct orbits. Geostationary satellites positioned at an altitude of approximately 22,000 miles above the equator remain fixated relative to the Earth's surface. These satellites facilitate crucial tasks such as telecommunications, broadcasting, and weather monitoring, providing continuous coverage over a specific region. In contrast, low Earth orbit satellites travel at lower altitudes, ranging from about 100 to 1,200 miles above the Earth. They move at a higher speed compared to geostationary satellites, enabling applications in Earth's observation, scientific research, and some communication services, including satellite-based internet. Additionally, medium Earth orbit satellites positioned between LEO and geostationary orbits are particularly utilized for navigation systems such as Global Positioning System, which is otherwise known as GPS. Polar orbiting satellites traverse the Earth from pole to pole, offering global coverage for various functions like weather monitoring and environmental observations. These satellites are launched into space by rockets and placed into specific orbits based on their intended roles, operating with onboard systems to maintain their positions and orbits. These satellites play a vital role in modern society, facilitating global communication, aiding navigation systems, monitoring weather patterns, contributing to scientific research, and supporting diverse technological advancements. Space Shuttle disasters. The Space Shuttle program, renowned for its achievements, encountered two devastating disasters that shook the space exploration community. The Challenger disaster on January 28, 1986, saw the tragic loss of the entire 7-member crew. A critical failure in the O-ring, allowing hot gases to escape from a solid rocket booster, led to the catastrophic explosion of the Challenger only 73 seconds after liftoff. The incident highlighted significant technical and organizational defenses, causing NASA to suspend the program for an extensive period to conduct thorough investigations and implement corrective measures to ensure enhanced safety and reliability. Subsequently, the Space Shuttle Columbia faced a catastrophic fate on February 1, 2003. During its re-entry into Earth's atmosphere, the shuttle disintegrated due to the damage sustained on launch. A piece-insulated foam from the external fuel tank struck the orbiter's left wing, resulting in critical damage to the thermal protection system. This allowed superheated gases to breach the wing during re-entry, leading to the tragic loss of all 7 crew members. Apollo 13. The Apollo 13 mission, launched on April 11, 1970, was the seventh crewed mission in NASA's Apollo space program and was intended to be the third lunar landing attempt. This crew consisted of Commander James Lovell, Command Module pilot John Swigert, and Lunar Module pilot Fred Hayes. However, the mission encountered a near catastrophic emergency when, 2 days after liftoff, an oxygen tank in the service module exploded, causing the spacecraft's main power, water, and oxygen to be compromised. This explosion also damaged other systems critical for the spacecraft's function. The crew heard a loud bang and felt a vibration, and shortly after, instruments showed up that the spacecraft was losing oxygen rapidly. Facing a life-threatening situation, the crew, with the help of mission control, worked tirelessly to conserve power, heat, and water, while fashioning a makeshift carbon dioxide removal system using materials on board the spacecraft. The command module was shut down and the crew transferred to the lunar module, which was used as a lifeboat. Their goal shifted from a lunar landing to a safe return to Earth. The LM was used as a lifeboat to provide the crew with necessary resources for survival and a means to control their return trajectory. They executed a critical engine burn on the far side of the moon to enable the spacecraft's trajectory to return to Earth. Despite numerous challenges, the crew successfully splashed down in the Pacific Ocean on April 17, 1970. The mission, although a failure in its original goal of landing on the moon, is widely regarded as a success failure due to the safe return of the astronauts under extremely difficult circumstances. Laika. Laika was a Soviet space dog, famously known as the first living being to orbit the Earth. Laika was a stray dog found on the streets of Moscow and was selected for the Soviet space program. She became part of the Soviet space mission Sputnik 2, launched on November 3, 1957. Laika's mission was a significant milestone in the history of space exploration, marking the first time a living being was sent into orbit. However, it was a one-day mission, as the technology to safely return living organisms from orbit had not yet been developed. Tragically, Laika's journey was not meant to bring her back to Earth. The spacecraft lacked the capability for her return or a recovery plan. It was an experimental mission to understand the effects on space travel on a living organism. Laika's presence and vital signs during the flight provided valuable data on the impact of space travel on living organisms, such as how a living being could survive the stress of space travel, including the effects of weightlessness and cosmic radiation. Sputnik 2 orbited the Earth for several days, but unfortunately, Laika did not survive the mission. It was later revealed that she passed away a few hours after reaching orbit due to stress and overheating within the spacecraft. Her sacrifice, however, contributed to advancements in space exploration and the understanding of the challenges and risks involved in sending living creatures into space. Alright, now on to Tier 4, starting off with the tyranny of the rocket equation. This refers to the fundamental concept in astronautics and space exploration that outlines the significant challenges and limitations imposed by the physics of rocket propulsion. This concept defines the crucial relationship between the mass of a rocket and the velocity it needs to reach the successful space mission. The rocket equation, formulated by Russian scientist Konstantin Chizovsky and later refined by others, describes the relationship between a rocket's velocity, exhaust velocity, and the rocket's mass, revealing the challenges and constraints involved in space travel. It fundamentally states that the velocity of a rocket can achieve is directly related to a mass ratio of the rocket and the fuel it carries. One of the key implications of this equation is the amount of propellant required to reach a specific velocity is not linear but exponential. As a rocket needs to carry its own fuel, the mass of the propellant required for the mission increases rapidly as the desired velocity or distance grows. As a result, a significant portion of the spacecraft's initial mass is dedicated to carrying the fuel needed to accelerate the craft, further adding to its mass and thus the fuel requirement. This results in diminishing returns and significantly impacts the efficiency and feasibility of a long-distance space mission. The tyranny lies in the fact that the more a rocket needs to accelerate, the more fuel it requires, which in turn increases the rocket's mass, making the task of achieving higher velocities or traveling further distances increasingly difficult, expensive, and technologically challenging. This equation shapes the design and feasibility of space missions, underscoring the critical importance of engineering efficiency and innovation in rocket design and space exploration. So, if that didn't make that much sense to you, it was pretty complicated for me as well, but pretty much what it's saying is the mass needed for rockets just keeps getting bigger and bigger because you need to keep adding more fuel to it. But then the more fuel, the more it weighs, and then so on. It's just an infinite cycle, but they figured it out eventually. Historic supernova. One of the most famous historic supernova is known as the supernova 1054, which led to the creation of the Crab Nebula. This supernova was a cataclysmic explosion of the star that was observed by astronomers and recorded in historical documents in the year 1054. This event resulted in the formulation of a nebula, initially observed recorded by Chinese astronomers as a guest star, visible in the daytime sky for almost a month. It was so bright that it was visible in the night sky for almost 2 years. Astronomers from various cultures, including Chinese, Japanese, Native American, and Arab astronomers, documented this sudden appearance of a new celestial object. The remnant of this supernova, known as the Crab Nebula, continues to be a prominent astronomical object visible in the constellation of Taurus. It is an expanding cloud of gas and dust resulting from the explosion, and it remains an important object to study for astronomers, offering insights into the life cycles of stars and the mechanisms behind supernova explosions. Supernova 1054 is known for a few historically recorded supernova, and its remnants continue to provide valuable data for scientists studying stellar evolution and the dynamics of these cosmic events. Stellar classification is a system used to categorize and describe stars based on their spectral characteristics, which reveal their temperature, color, size, and stage of evolution. The most commonly used stellar classification system is the Morgan-Kinnan system, otherwise known as the MK system, which employs a combination of spectral types and luminosity classes. The spectral classification system organizes stars into different categories based on the characteristics of their spectra. The spectral classes and types are denoted by letters, which are O, B, A, F, G, K, and M, which represent the temperature and color of the stars. Each spectral type is further divided into subclasses indicated by numerical value through 0 through 9. The sequence from hottest to coolest is O, B, A, F, G, K, and M, with O-type stars being the hottest and M-type stars being the coolest. Another aspect of classification is the luminosity class, which characterizes stars based on their size and brightness. It uses Roman numerals, which are 1, 2, 3, and then the I4, and then the IV, and then so on, to represent different stages of stars' evolution and size, ranging from supergiants to main sequence stars to dwarfs. For example, our Sun is classified as a G2V star, signifying a Jeep-type star of moderate temperature and size in the main sequence. In addition to the main classes, there are less common spectral types, such as L, T, and Y, which are used to classify brown dwarfs and other celestial objects. This classification system helps astronomers understand the properties, behavior, and evolutionary stars of other stages, enabling them to identify and characterize stars based on their unique characteristics observed in their spectra. And I know the last two entries so far have been pretty, in-depth and more scientifical and stuff like that, and it won't be like that through the rest of the Iceberg, but there is a few of these littered throughout this. TV static. In the context of outer space, the term TV static is sometimes used as a metaphor to describe certain cosmic phenomena. It's an attempt to illustrate the appearance of the background radiation or faint speckled patterns that can be observed in space when scientists study cosmic microwave background radiation or the distribution of matter across the universe. Cosmic microwave background radiation is a faint glow of radiation that permeates the entire universe. It is remnant of the early universe, originating from about 380,000 years after the Big Bang, when the universe became transparent to light. This radiation is observed in all directions and represents the oldest light in the universe. When described as TV static, it's an analogy used to depict the visual appearance of this faint radiation, like the random noise or grainy pattern seen in TV static. Cosmic microwave background radiation appears as a seemingly random pattern when visualized through detectors and instruments used by astronomers. This radiation provides essential clues about the early universe's structure, the formation of galaxies, and the age of the cosmos. Cosmic rays. Cosmic rays are high-energy charged particles originating from space that travel through the universe at nearly the speed of light. They consist of atomic nuclei, mostly protons and atomic nuclei from various chemical elements, as well as some from electrons, positrons, and other subatomic particles. These particles arrive at Earth from various sources, such as supernovas, active galactic nuclei, and other astrophysical events occurring outside our solar system. The origins of cosmic rays are diverse. Some cosmic rays are believed to be generated within our galaxy, while others might originate from outside the Milky Way. However, their exact sources and acceleration mechanisms are not entirely understood. Upon reaching the Earth's atmosphere, cosmic rays collide with modules in the air and producing a cascade of secondary particles. These secondary particles interact and produce additional particles in what's known as extensive air shower, which can be detected by ground-based observatories and detectors. Studying cosmic rays helps scientists understand astrophysical phenomena such as violent processes occurring in stars and other cosmic objects that accelerate these particles to extremely high energies. Additionally, the study of cosmic rays offers insights into fundamental particle physics and contributes to understanding the behavior of matter and energy under extreme conditions in the universe. Micrometeorites are tiny particles of extraterrestrial material, usually small flecks of rock or metal, that enter the Earth's atmosphere and reach the surface without burning up completely. These micrometeorites are often the remnants of asteroids, comets, or other celestial bodies that have disintegrated or broken apart as they traveled through space. These particles are typically very small, usually ranging in size from a fraction of a millimeter to a few millimeters. Some can even be smaller, reaching the sub-millimeter or micron scale. Due to their diminutive size and low mass, they don't cause any damage when they enter the Earth's atmosphere and gently settle on the planet's surface. They can be found virtually anywhere on Earth, but they are more easily collected in areas less affected by human activity, such as polar regions, remote deserts, or on ocean beds. Scientists collect and study micrometeorites to better understand the composition of extraterrestrial matter, the evolution of celestial bodies, and the processes that occur in space. The Kuiper Belt, an extensive region located beyond Neptune in the outer reaches of our solar system, is a celestial zone teeming with icy objects, debris, and dwarf planets, spanning roughly 30 to 55 astronomical units from the Sun. This belt is a repository of remnants from the early stages of our solar system's formation, composed mostly of frozen volatile substances like water, methane, and ammonia. These icy bodies offer a glimpse into the primordial materials from which planets and other celestial bodies emerged. Among its members are notable dwarf planets such as Pluto, Aries, Makemake, and Humanae. The Kuiper Belt was captured the attention of astronomers and space explorers with the New Horizons spacecraft's historic flyby of Pluto in 2015, providing groundbreaking insights into the distance and enigmatic region. This area's study not only sheds light on the diverse compositions of celestial objects, but also deepens our understanding of the evolution and conditions of the early solar system. The Oort Cloud, a conceptual region far beyond the Kuiper Belt in the outermost part of our solar system. It's placed as a vast and spherical collection of icy objects, remnants from the solar system's earliest parts, and though not directly observed, it's believed to stretch from around 2,000 astronomical units to an astonishing 100,000 astronomical units from the Sun. This hypothetical expanse is composed of icy debris, likely containing frozen volatiles such as water, ammonia, and methane, remnants from the solar system's formative years. The Oort Cloud is theorized to be the source of long-period comets, though the orbital periods extending from hundreds or even thousands of years, which occasionally venture closer to the Sun due to gravitational disturbances or interactions with passing stars. Despite its speculative nature, the theoretical presence of the Oort Cloud provides an explanation for the origin of the long-period comets and essential insights into the early evolutionary stages and dynamics of the solar system. Antimatter. Antimatter is a material composed of antiparticles. These have the same mass as particles of ordinary matter, but have opposite charge and properties, such as lepton and baryon number. Encounters beyond a particle and antiparticle led to both of them being destroyed. So basically every particle that's positive that we can see, there's just an opposite one that's the exact same. So pretty simple. Corned beef sandwich. And I'm not really sure what this entry is even referring to. I couldn't find that space missions follow a corned beef sandwich diet or anything like that. So if anyone knows anything about corned beef sandwich in space or outer space, let me know. The Fermi paradox, and I personally love this just paradox and idea as a whole, and I might make a video on it someday because it's just so thought-provoking about why there hasn't been any extraterrestrial civilizations found. But let's get into this entry. And the extraterrestrial civilizations about the lack of evidence or contact with such civilizations. Named after the physicist Enrico Fermi, the paradox possesses the question: if there's a high likelihood of advanced extraterrestrial civilizations in our vast universe, why haven't we detected or encountered any yet? This apparent paradox revolves around several key considerations: the vastness of the universe. The universe is immense, hosting billions of galaxies, each containing billions of stars, many of which are likely to have Earth-like planets. The probability of habitable planets and potential extraterrestrial life appears high, and the abundance of time. Given the vast age of the universe, many civilizations could have arisen and potentially developed advanced technology long before human civilization. Some of these civilizations might have ample time to advance technologically and explore the cosmos. Lack of evidence. Despite extensive searches, we have not found any evidence of extraterrestrial civilizations, such as radio signals, artifacts, or other signals of advanced technology. Various hypotheses and explanations attempt to address the Fermi paradox, including the possibility that extraterrestrial civilizations might just be really rare, that they might be deliberately avoiding contact, or that advanced civilizations might destroy themselves before making contact. Additionally, it's plausible that our current technological capabilities are insufficient to detect any other civilizations, or that the distances between stars and galaxies are simply too vast for direct contact or communication. The Fermi paradox stimulates discussions and ongoing research in fields such as astronomy, astrobiology, and SETE, which is the search for extraterrestrial intelligence. Alright, now on to Tier 5, starting off with the interstellar journey times, or the duration required for spacecraft to travel between stars, present a significant challenge due to the vast distances involved in interstellar space. The vastness of space, combined with current technological limitations, poses considerable obstacles to achieving practical interstellar travel. The time it takes to travel between stars depends on the speed of the spacecraft and the distance to the target star. The closest star system to our solar system, Alpha Centauri, is approximately 4.37 light-years away. For conventional spacecraft utilizing current propulsion systems, the travel times to reach even the nearest star would be incredibly long. For instance, Proxima Centauri, the closest known exoplanetary system, is around 4.24 light-years away. At the speed of current spacecraft, such as the Voyager 1, which travels at about 17 kilometers per second, it would take over 70,000 years to reach the star. Hypothetically, if a spacecraft were able to achieving a significant fraction of the speed of light, say 10%, the travel time to Proxima Centauri would still be around 40 years. Achieving faster than light travel, as seen in science fiction, is currently beyond our scientific understanding and technology, and theoretical concepts such as wormholes or warp drives have been explored, but their feasibility and practical implementation remain highly speculative and reliant on hypothetical physics. N-1 Secret Moon Rocket. The N-1 was a colossal and ambitious Soviet rocket designed for manned lunar missions during the space race era in the 1960s and 1970s. It was specifically intended to propel Soviet cosmonauts to the moon as part of the USSR's lunar program. Attempting to rival the United States' successful Apollo program, the N-1 rocket stood as the Soviet response to the American Saturn V rocket, which had successfully carried astronauts to the moon. The N-1 was distinctive for its enormous size and the use of powerful engines to propel it beyond Earth's orbit. Unfortunately, the N-1 program faced numerous setbacks and technical challenges. The N-1 had a complex design with 30 engines in the first stage alone. The first 4 test launches of the N-1 between 1969 and 1972 ended in failure. The second launch, which took place on July 3, 1969, resulted in the destruction of the rocket only seconds after liftoff, leading to a massive explosion. The failures of the N-1 program, coupled with the success of the American Apollo program, resulted in the Soviet Union ultimately abandoning its lunar ambitions. Following the multiple failures and the success of the American Apollo 11 mission that landed the first humans on the moon, the Soviet Union shifted its focus toward other space missions, including space stations and unmanned exploration. The N-1 rocket's failures contributed to the cancellation of the Soviet manned lunar program and represented a significant setback in the USSR's quest for lunar exploration during the space race. Lost Cosmonauts Conspiracy Theory. The Lost Cosmonauts Conspiracy Theory revolves around the idea that the Soviet Union had allegedly launched cosmonauts into space before Yuri Gagarin's historical flight in 1961, but these missions were concealed or ended in disaster, leading to the loss of the astronauts' lives. This theory suggests that the Soviet space program might have hidden unsuccessful space missions or accidents involving cosmonauts to maintain an image of success in the space race against the United States. The theory gained traction after the collapse of the Soviet Union, when some individuals claimed to have intercepted or heard secret transmissions from failed or lost Soviet space missions using amateur radio equipment. These alleged intercepted transmissions purportedly suggested that other cosmonauts might have been sent into space prior to Gagarin's successful mission that never returned. However, mainstream historians, space experts, and many in the scientific community consider the lost cosmonauts theory as lacking substantial evidence and credibility. There's no solvable, verifiable proof, but who knows, maybe there was lost cosmonauts somewhere out there in space. Dark matter, a mysterious and invisible substance, represents a significant portion of the universe's mass. It does not emit, absorb, or reflect light, making it undetectable by traditional means. However, its presence is inferred from its gravitational effects on galaxies, galaxy clusters, and the large-scale structure of the universe. Although undetectable directly through telescopes, dark matter influences visible matter gravitationally, playing a pivotal role in holding galaxies together and affecting the motion of stars within them, as well as the motion of galaxies in the clusters. Its cosmological significance lies in its believed impact on the formation of galaxies and other cosmic structures. The quest to understand dark matter includes various different experiments, astronomical observations, and simulations aimed at identifying its constituents and unraveling the mystery surrounding this enigmatic substance. Moon dust is dangerous. Moon dust, also known as lunar regolith, presents challenges and potential hazards for human exploration and equipment on the moon, composed of fine abrasive particles formed by constant meteoric impacts on the lunar surface. This dust poses risks to both astronauts and machinery. Its abrasive nature can damage equipment, potentially affecting mechanical parts and instruments, and however, the fine particles can cling to spacesuits and surfaces, potentially causing health issues if inhaled or in contact with human skin, as studies suggest its toxicity and or irritant properties. These particles, due to their electrostatic charge, can be challenging to remove from spacesuits and equipment. To address these challenges, ongoing research focuses on developing different technologies to help get rid of this moon dust that sticks to astronauts and the machines. Diamond planets are a theoretical type of exoplanet that might contain vast amounts of carbon in various different forms, potentially including crystalline structures resembling diamonds. These planets are largely theoretical and hypothetical, and none have really been observed or confirmed yet. Diamond planets are conceptualized as celestial bodies that could possess high carbon content due to different conditions in their formations, such as having a composition enriched in carbon or enriching extreme pressures and temperatures that could lead to the creation of large amounts of carbon compounds, including diamond. Astronomers theorize that rich carbon planets could exist in environments where carbon is abundant, potentially forming diamonds due to the high pressure and temperature. In some cases, if a star system has an excess of carbon and minerals, it might influence the composition of the planets forming in that system, leading to the theoretical possibility of a whole diamond planet. The study and search for exoplanets continue, and while we have not really discovered any planetary types, no direct evidence or observation has confirmed a diamond planet. Solar sails are a form of spacecraft propulsion that harnesses the momentum of photons, which are particles of light, from the sun to propel a spacecraft through space. These sails utilize the pressure of sunlight, which, although individually very weak, can exert a force on a large, lightweight, reflective surfaces. The basic concept involves deploying a large, thin, reflective sail in space. As sunlight interacts with the sail's surface, the transfer of momentum occurs due to the reflection and absorption of the photons. These continual transfer of momentum provides a small but consistent acceleration, propelling the spacecraft forward without the need for traditional propellants or engines. The benefits of solar sails include their potentiality for long-duration space missions, as they can continuously receive propulsion from the sun's light, allowing spacecraft to reach high velocities over time. They are particularly useful for missions that do not require rapid acceleration but can benefit from continuous and low-energy propulsion. The flags on the moon are now white. The flags planted on the moon during the Apollo missions have likely undergone significant changes due to the exposure to extreme conditions on the lunar surface. Over time, the flag's colors may have been bleached or faded due to the unfiltered, harsh sunlight, extreme temperature variations, and exposure to solar radiation and micrometeorite impacts. The flags placed by the Apollo astronauts were predominantly made of nylon, and though they were reported to have anodized aluminum frames to maintain their shape, the flags themselves were not designed to withstand the harsh lunar environment for extended periods. Consequently, the prolonged exposure to ultraviolet radiation and temperature fluctuations on the moon might have caused the colors to fade and the flags to deteriorate. While challenging to confirm the exact current condition of the flags without recent direct observations, it is widely believed that the flag's original colors might have significantly altered due to the extreme conditions of the lunar surface. Cosmic inflation, a concept in cosmology, proposes a phase of rapid and exponential expansion that occurred in the universe's earliest months. Shortly after the Big Bang, this theory was developed to address specific issues and observations in the standard Big Bang model, particularly the uniformity and structure of the cosmos. It suggests that in a fraction of a second after the Big Bang, the universe underwent an incredibly swift expansion, enlarging in size by an enormous factor within an extremely brief time frame, roughly between 10 to the 36 power seconds after the Big Bang. The idea of inflation proposes an explanation for the observed homogeneity and isotropy of the universe, accounting for the uniformity in the cosmic microwave background radiation and the consistency in temperature across the vast expanse of the observable universe. Despite regions being seemingly out of casual contact, inflation helps to address the remarkable consistency in temperature and structure, offering a framework for how the universe acquired its uniform nature. While the precise mechanisms and details of inflation continue to be the subject of ongoing research and exploration, this theory can become an integral part of the prevailing Big Bang model. Apollo 1 was the designation for the first manned mission in NASA's Apollo program, intended to test the command and service module in Earth's orbit. However, the mission encountered a tragic accident during a pre-launch test on January 27, 1967, resulting in the loss of 3 astronauts: Virgil Gus Grissom, Edward H. White II, and Roger B. Chaffee. The accident occurred during a plugs-out test where the spacecraft's command module was being tested under its own internal power without being connected to the ground facilities. A spark in the pure oxygen atmosphere of the command module ignited a fire, rapidly spreading in the cabin due to the flammable materials, while it led to the tragic loss of the crew. The investigation that followed revealed numerous design and safety flaws in the spacecraft's construction and led to substantial changes in the Apollo program's safety protocols and spacecraft design. Mir incidents. The Russian space station Mir, operational from 1986 to 2001, encountered several incidents and challenges during its tenure in orbit. One of the most significant incidents occurred in 1997 when a fire broke out due to an oxygen-generating canister, causing substantial damage and sparking an emergency situation. The crew managed to extinguish the fire, but the incidents raised concerns about safety and highlighted the potential risks of operating an aging space station. Mir also faced collisions and technical malfunctions throughout its operational years. In 1997, a cargo spacecraft collided with Mir during a docking attempt, causing damage to the Spectre module and resulting in the loss of power. The space station encountered small technical glitches as well, including issues with power supply and cooling systems, which demanded swift and resourceful solutions from cosmonauts and ground control to stabilize the situation. Despite these challenges, Mir served as an important platform for human space flight experience, long-duration missions, and scientific research, fostering international collaboration in the whole space exploration. Acceleration and gravity equivalence. The equivalence between acceleration and gravity, proposed by Albert Einstein's theory of general relativity, states that there's an indistinguishable relationship between the effects of acceleration and gravitational fields in a local region of space-time. In this principle, if one were in a sealed environment experiencing uniform acceleration, akin to being pushed against the floor, the sensation would mimic the force felt due to gravity on Earth. This concept implies that gravitational fields and accelerated reference frames are fundamentally linked, suggesting that gravity, rather than being a force between two masses as Newtonian physics described, is better understood as the curvature of space-time caused by mass and energy. This fundamental equivalence principle forms the basis of Einstein's exploration of gravity and the relationship to the curvature of space-time, offering profound insights into our understanding of the nature of gravity and its effects on the fabric of the universe. Titan Lakes. Titan, Saturn's largest moon, is notable for its vast liquid hydrocarbon lakes and seas, making it the only celestial body in our solar system, aside from Earth, known to have stable bodies of liquid on its surface. The lakes and seas on Titan are primarily composed of liquid methane and ethane, which are in a liquid state due to the extremely low temperatures and high atmospheric pressure on the moon. Some of these lakes and seas cover substantial areas, with Kraken Mare being the largest known body of liquid on Titan, estimated to be larger than the Caspian Sea on Earth. The Cassini spacecraft during its mission observed and mapped these liquid features on Titan's surface, revealing their diversity, distribution, and composition. These lakes and seas have distinct features and shorelines, suggesting that they undergo processes similar to Earth's bodies of waters, such as evaporation, rainfall, and the formation of river-like channels. Wow signal. The wow signal refers to the intriguing and unexplained radio signal detected by the Big Ear radio telescope at Ohio State University on August 15, 1977. Astronomer Jerry R. Ammon noticed an unusually strong and narrowband radio signal picked up by the telescope while it was conducting a sky survey to search for extraterrestrial signals. The signal was named WOW due to Ammon's handwritten comment on the computer printout of the data where he circled the alphanumeric sequence 6EQUJ5 and wrote WOW next to it. The signal was notable for strength and narrow frequency, lasting for about 72 seconds before disappearing. It was observed in the 1420 MHz frequency, where it was significant as the frequency is within the range of hydrogen, the most abundant element in the universe, naturally emits radio signals. Alright, now on to Tier 6, starting off with Vladimir Komarov's sacrifice. Vladimir Komarov was a Soviet cosmonaut who tragically lost his life during the Soyuz first mission, which launched on April 23, 1967. The mission encountered various technical problems and ultimately ended in a fatal crash, making Komarov the first human to perish during a space mission. The Soyuz 1 mission was fraught with technical issues from the start. Malfunctions in the spacecraft systems occurred, including issues with the solar panels and the primary parachute. Despite these problems, Komarov bravely attempted re-entry, fully aware of the high risks involved. He knew the dangers that craft faced it, but he refused to abandon the mission, fully understanding the critical importance of his role. The attempted return to Earth proved fatal when the spacecraft's parachute failed to deploy correctly during the descent, and the capsule plummeted to the ground, resulting in a crash that tragically took Komarov's life. Komarov's sacrifice remains a significant and somber event in the history of space exploration. His bravery and dedication, even in the face of known risks and technical issues, serve as a testament to the dedications of early astronauts in their pursuit of space exploration. Gay astronauts. there have been several astronauts who identify as LGBTQ+, and have contributed significantly to space exploration. Notably, some have come out publicly after their time as astronauts, while others have shared their experiences following their career in space. For instance, former NASA astronaut Sally Ride, the first American woman in space, came out as lesbian after her astronaut career. Similarly, Charles B. Bolden Jr., a former NASA administrator and retired astronaut, expressed his support for LGBTQ+ rights and representation in STEM fields. While he did not publicly come out as gay during his tenure as an astronaut, he has been an advocate for diversity and inclusion in the aerospace community. Quasars, abbreviated from quasi-stellar radio sources, represent some of the most luminous and energetic objects in the cosmos. Fueled by supermassive black holes at the centers of the galaxies, these celestial powerhouses emit vast amounts of electromagnetic radiation across the spectrum. Their exponential brightness can outshine entire galaxies, releasing energy equivalent to hundreds of galaxies combined, encircled by a swirling exertion disk of superheated gases and dust. These supermassive black holes draw in surrounding material, generating immense energy as it falls into the black hole. The light emitted by quasars is often highlighted red-shifted, indicating their great distance from Earth, providing a glimpse into the early stages of the universe's development. Carrington event, occurring in 1859, stands as a monumentous solar storm that resulted from a solar flare and a subsequent coronal mass ejection from the sun. Named after astronomer Richard Carrington, who observed the initial solar flare, this event triggered an intense geomagnetic storm upon its arrival at Earth. The impact led to dazzling auroras visible at unusually low altitudes, while causing widespread disruptions to telegraph systems. Telegraph operators reported induced electrical currents in wires, resulting in shocks, fires, and equipment malfunctions. This historic event remains significant as it illustrates the potential effects of extreme space weather on our actual planet and highlights the importance of understanding and preparing for such occurrences, especially in the context of our modern, technologically reliant society. Tabby's star, scientifically known as KIC 8462852, drew attention due to its irregular and enigmatic changes in brightness observed by NASA's Kepler Space Telescope. These alterations in luminosity were highly unusual, displaying abrupt and inconsistent dips that did not align with typical stellar behavior or known planetary transits. Scientists proposed several different theories to account for these irregular dimming patterns, including comet swarms, asteroid collisions, or uneven dust clouds, yet none could entirely explain the observed anomalies. One particularly speculative suggestion capturing public interest proposed the possibility of an alien megastructure, like a Dyson sphere, causing the irregular obstruction of the star. Despite numerous investigations and follow-up observations, a definitive explanation for the atypical fluctuations in Tabby's star brightness remains elusive, leaving it as an intriguing enigma within the realm of astrophysics. So what do you think? Is it just comets swarming the star, or is it an alien megastructure? Saturn's rings will disappear. Saturn's rings, primarily composed of icy particles and debris, face gradual erosion and depletion, influenced by collisions, gravitational interactions with Saturn's moons, and solar radiation pressure. Estimates suggest that potential disappearance in tens to hundreds of millions of years. Surprisingly, they might not be as ancient as the planet itself, potentially forming relatively recently and possibly dissipating and reforming multiple times over and over and over in Saturn's lifespan. Solar eclipses are a coincidence, and funny enough, I found nothing online showing that they are actually a coincidence, and everything pointing that they are just not coincidence at all, and it's just not a coincidence, like I said. So I'll just explain why they aren't a coincidence, and instead they are meticulously orchestrated celestial events driven by the precise alignment of the sun, moon, and earth. These extraordinary occurrences unfold when the moon moves between the earth and the sun, casting a shadow on our planet. From a solar eclipse to manifest, these cosmic bodies must align almost perfectly, and this synchronized is far from random. Eclipses primarily take place during the new moon phase, where the moon positions itself squarely between Earth and Sun. However, eclipses are not daily phenomena phenomena, of course, because the moon's orbit tilts slightly concerning Earth's orbit around the sun. This misalignment means that the most new moons do not culminate in an eclipse. Solar eclipses come in various forms, including total, partial, and annular, contingent of the specific positioning and distance between the sun, moon, and Earth. This regularity and predictability of solar eclipses are a testament to the stable orbits of these planets, and so they aren't coincidences like the entry said. But if anyone wants to argue in the comments, go ahead. Gravity is not a force. In the framework of general relativity, gravity is not considered a force in the traditional Newtonian sense, but rather a consequence of the curvature of space-time caused by the presence of mass and energy. According to Albert Einstein's theory, massive objects such as planets, stars, and galaxies curve the fabric of space-time, and this curvature determines the paths that other objects follow. Objects move along what they perceive as straight lines within this curved space-time, creating the appearance of gravitational attraction. In this context, gravity is not a force acting between two objects, but rather the result of the way matter and energy bend the fabric of the universe, influencing the motion of objects within that curved space where we are. So it's not technically gravity, it's technically the Earth and the space-time and stuff like that. Pretty complicated, but I hope I explained it decently. Martian canals. The idea of Martian canals was a historical concept born from a 19th century observations of Mars. Italian astronomer Giovanni Scarpelli, known for his meticulous observations of Mars, used the term canali to describe the linear features he observed on the Martian surface. However, canali was mistranslated into English as canals, which implied artificial structures rather than natural formations. These perceived canals sparked public fascination and speculation that intelligent beings might have constructed these long, straight features to channel water from the polar ice caps across the Martian surface. These notion gained attention and inspired many to theorize about the possibility of life and aliens on Mars. Later observations from more advanced telescopes, particularly those from the Mariner and Viking missions in the 1960s and 70s, provided more detailed and accurate images of Mars. These observations revealed that the canals were natural formations, such as geological features, ridges, or optical illusions. The canals observed by Scarpelli were likely created due to limitations in the telescopic technology of that time, combined with the human tendency to perceive patterns where they don't exist at all, a phenomenon known as pareidolia. Human ashes in the outer solar system. Sending human ashes or remains to the outer solar system, particularly beyond Earth's orbit, is a concept that has been proposed and to some extent actually carried out. For example, some missions like the New Horizons spacecraft, which flew by Pluto, and the Cassini mission, which orbited Saturn, have carried a nominal amount of human remains or symbolic portion of cremated ashes aboard. These instances have involved small quantities of ashes contained within a secure and well-sealed compartment as part of outreach or memorial efforts, allowing individuals to honor deceased loved ones by sending a symbolic portion of their remains on missions exploring the outer reaches of the solar system. However, due to the vast distances and harsh conditions in the outer solar system, where spacecrafts can encounter extreme cold, radiation, and other challenges, sending human ashes or remains beyond Earth's orbit is primarily symbolic and not intended for burial or scattering in the conventional sense. Space-time might be 4D. In modern physics, space-time is commonly conceptualized as a fourth-dimensional construct, combining the traditional three dimensions of space with an additional dimension of time. This depiction of space-time as a unified continuum is a foundational concept in Einstein's theory of special and general relativity. It integrates the three spatial dimensions, length, width, and height, how we all see it, with time as the fourth dimension, creating a single framework where events and interactions in the universe occur. This fourth-dimensional space-time continuum allows for a comprehensive understanding of the interwoven nature of space and time, offering insights into the behavior of matter, energy, gravity, and the fundamental structure of the cosmos. While human perception often distinguishes space and time as separate entities in the domain of modern physics, they are intrinsically linked with the unified concept of space-time. Buran was the Soviet Union's response to the United States Space Shuttle program, envisioned as a reusable spacecraft for space missions. Developed during the 1970s and 80s, the spacecraft was named Buran, signifying snowstorm or blizzard in Russian. Resembling the U.S. Space Shuttle, but with some design differences. Buran was equipped with both cargo and crew transport, featuring a payload bay for satellite deployment and retrieval. Notably, its flight system was more automated compared to the American counterpart. In its only orbital flight on November 15, 1988, an unmanned test mission was launched atop a rocket. The spacecraft completed 2 orbits before a successful return and landing. However, despite this successful test, the program was halted due to the collapse of the Soviet Union and financial constraints. Only one operational Buran orbiter was constructed, and the program was ultimately discontinued. Tragically, the sole completed spacecraft was destroyed in 2002 due to the collapse of the hangar housing the craft. Buran, though short-lived, remains a testament to the Soviet advancements in space technology and serves as a brief but significant chapter in the history of space exploration. Soyuz 11 represented the Soviet Union's groundbreaking attempt in 1971 to transport a full crew to the Salyut-1 space station for an extended stay. The mission was intended to enable scientific research and experiments on board the space station. The crew, comprising Georgy Dobrovsky, Viktor Patsayev, and Vladislav Volkov, ventured into space to conduct a series of tasks as part of this pioneering mission. However, tragedy struck during the re-entry to Earth on June 30th, 1971. A premature opening of a cabin air vent resulted in the rapid venting of the crew's life-supporting atmosphere into space. Sadly, the cosmonauts, who were not wearing any spacesuits during the re-entry, were asphyxiated before the spacecraft landed. While the landing itself was successful, the crew was found deceased upon recovery. The loss of the Soyuz 11 crew was a devastating incident, marking the only known human deaths directly attributed to a space mission. It led to a significant reevaluation of safety protocols and helped design other rockets in the future. Alright, now on to Tier 7, starting off with the Pioneer Anomaly. The Pioneer Anomaly refers to the unexplained deviation noticed in the trajectories of the Pioneer 10 and Pioneer 11 spacecraft as they journeyed beyond our solar system. Launched in the early 1970s, these probes exhibited an unexpected deceleration, a small and constant sunward acceleration. Once they ventured past the gravitational influences of the outer solar system, the unanticipated decrease in speed could have reconciled by known gravitational forces, leading to various proposed explanations, including asymmetric heat radiation, gas leaks, or unaccounted for gravitational interactions beyond the solar system. Despite extensive investigations, no definitive explanation has been established, leaving the Pioneer Anomaly as an enduring mystery in space exploration. Martian waterfall. While evidence from various spacecraft, such as the Mars Reconnaissance Orbiter, has suggested the existence of ancient river valleys, lake beds, and even the possibility of intermediate seeps of briny water, the notion of a conventional Earth-like waterfall with freely flowing water on Mars has not been observed or confirmed, but it's possible that once in the history of Mars, there was a waterfall-like water feature that existed, and maybe we will come across one sooner than later as we keep going and discovering more of Mars. Space blindness, known scientifically as spaceflight-associated neuroocular syndrome, and that's a hell of a name for space blindness, but otherwise known as SANS or SANS, presents various visual impairments observed in astronauts after prolonged stays in space. Symptoms include blurred vision, focus difficulties, and changes in visual acuity, along with alterations in eye structure, such as modifications in the shape of the eyeball and retinal nerve. Swelling on the optic nerve is also reported among affected individuals. The causes of SANS are believed to be linked to prolonged exposure to microgravity, which disrupts fluid distribution in your body, leading to fluid shifts and increased intracranial pressure. These changes can affect the eyes and visual acuity, posing potential risks for astronauts both during and after space missions. The implications of SANS are significant, potentially impacting the performance of crucial tasks while in space and raising concerns for long-term visual health post-mission. STS-7 window damage. The seventh mission of NASA's Space Shuttle program faced an unusual incident involving window damage. Launched on June 18, 1983, STS-7 carried the Space Shuttle Challenger and marked several milestones, including the first American woman in space, astronaut Sally Ride. During this mission, a small dent was noticed on one of the orbiter's windows. The source of the damage was found to be a fleck of paint or other minuscule debris that collided with the window at high speeds, causing a tiny pit in the glass. The damage was not considered to be a significant threat to the mission's safety, and the orbiter continued its flight without any major concerns. NASA's engineers and experts thoroughly examined the window and deduced that it did not pose any risk of compromising the shuttle or the crew's safety. Oumuamua Spaceship Conspiracy. This interstellar object known as Oumuamua, detected in 2017 as it passed through our solar system, sparked a variety of hypotheses, with one of the most sensational being the speculation that it might be an alien spaceship. Its unusual features, particularly its elongated shape and atypical trajectory, led to speculation about its potential artificial origin. Oumuamua's lack of observable comet-like activity added to the intrigue, as it did not display the expected tail or typical features associated with natural celestial bodies. Some propose that its non-gravitational acceleration might suggest artificial propulsion. However, the scientific community largely leaned towards natural explanations for Oumuamua's characteristics. Astronomers suggested that the object might be fragmented from a disintegrated body or planet or a particularly shaped asteroid or comet. While the idea of Oumuamua being an alien spaceship was an intriguing theory, it lacks substantial evidence to support it and remains speculative. Dark energy, a hypothetical form of energy, constitutes approximately 68% of the total energy content in the universe. Its existence is proposed to explain the observed accelerated expansion of the cosmos. The concept of dark energy emerged from observations that revealed the universe's expansion is not only ongoing but accelerating. So the universe is just constantly getting bigger and bigger, but at the same time going faster and faster, getting bigger and bigger, obviously just faster every time. It's believed that dark energy is the force behind the accelerated expansion, countering the gravitational pull between galaxies. Dark energy is associated with a negative pressure and is thought to be uniformly distributed throughout space, acting as a repulsive force on the cosmic scale. However, the true nature and origin of dark energy remains largely unknown, and the concept of cosmological constant, initially proposed by Albert Einstein in his theory of general relativity once again, is one explanation for this enigmatic force. Other theories suggest it might be associated with hypothetical fields that dynamically influence the properties of space. Understanding dark energy is crucial in cosmology as it significantly influences the future fate and structure of the entire universe. The Great Attractor, discovered in the 1970s, is a prominent region in space located hundreds of millions of light years away from Earth. It's recognized for its significant gravitational influence on galaxies within our cosmic neighborhood. Inferred from the observed motion of galaxies in the universe, this gravitational anomaly exerts a powerful pull on nearby galaxies, causing their movement to converge towards it. Despite its influential force, direct observation of the Great Attractor is challenging due to its position obscured by the dense core of our Milky Way galaxy. This obstruction hinders the ability to study it using visible light. The Great Attractor isn't a single massive object, but rather a region influenced by a collective gravitational pull of multiple galaxy clusters and superclusters. It represents an area where the density of matter is notably higher than its surrounding cosmic environment. So, who knows, maybe in the future we'll see what the Great Attractor is, but it's kind of scary to me for some reason. String theory. The string theory is a theoretical framework in physics aiming to describe the fundamental components of the universe. It proposes that particles aren't zero-dimensional points but tiny, vibrating one-dimensional strings. These strings vibrate at varying frequencies, producing different particles based on their vibrational modes, offering a way to understand particle properties. Additionally, string theory suggests that existence of extra dimensions beyond the familiar three spatial dimensions, which are thought to be complicated and exceedingly small. These theories suggest to reconcile quantum mechanics and general relativity, aiming to provide a unified explanation of the four fundamental forces of nature. Despite its promise, string theory faces challenges in experimental verification due to the need for extremely high energies, making direct confirmation or refutation difficult. Venusian dinosaurs. Venus has always captured the attention of humanity. Of all the objects that are in our night sky, it's the brightest, excluding the moon, and peering through his telescope in the early 17th century, Italian astronomer Galileo Galilei found Venus to be almost featureless. What he saw was Venus's defining, impenetrable layer of thick clouds, obscuring the surface and shrouding the planet in mystery, a mystery quite open to speculation. And one of the most outlandish, yet surprisingly common lines of his speculative reasoning was, quote, "I can't see a thing on the surface of Venus." Why not? Because it's covered with a dense layer of clouds. Well, what are clouds made of? Water, of course. Therefore, Venus must have a lot of water on it. Therefore, the surface must be wet. Well, if the surface is wet, it's probably a swamp. If there's a swamp, there's ferns. If there's ferns, maybe there's even dinosaurs, end quote. And that's really interesting to me how he just went down that quick rabbit hole and ended up thinking Venus had dinosaurs on it. The original observation was effectively a lack of an observation. The conclusion was dinosaurs. For decades and decades, this faulty logic played out harmlessly, rolling imaginations and powering the pens of scientific fiction writers. Published in 1895, Gustavus W. Pope's Journey to Venus weaves the tale of a fantastical trek to Earth's sister planet, placing Lieutenant Frederick Hamilton and his companion, the Martian princess Sumalia, in a lush Venusian landscape inhabited by vicious dinosaur-like beasts, exciting adventures, hair-breadth escapes, and perilous vicissitudes, end quote. Ensue according to the book's publisher. In 1922, fantasies of a wet, swampy Venus started to fade. Astronomers analyzing the visible light reflected from the planet's atmosphere found no signs of the wavelengths which would have given off oxygen or water. Venus, then, they proposed, may instead be barren and dusty, a desert-like place. Venus is, of course, named after the Roman goddess of love and beauty, and this new scientifically modern depiction wasn't nearly romantic or poetic enough for the novelists. So what did many of them do? They simply ignored it. Even as late as 1950s, writers were still describing the planet as wet and rainy. Ray Bradbury's The Long Rain told the story of 4 men who crash-landed on the planet and were subsequently driven insane by the unceasing perspiration. Quote, "It was hard rain and a perpetual rain," Bradbury wrote, "a sweating and steaming rain. It was like a missile, a downpour, a fountain, a whipping in the eyes, an undertow at the ankles. It was a rain to drown all rains in the memory of all the rains," end quote. We now conclusively know that there is no rain on Venus, not even a drizzle. The planet's sizzling environment, sporting temperatures in excess of 800 degrees Fahrenheit, vaporized liquid long ago. With this knowledge, we can revise the aforementioned line of reasoning to reach a more correct conclusion. There is no water, therefore there are no ferns, therefore there are no dinosaurs. And this single-handedly was my favorite on the iceberg because it's just such an interesting theory and something tons of people thought for a long time that Venus had dinosaurs on it. But really interesting and definitely my favorite on the iceberg. Many worlds. The many worlds theory, a concept within quantum mechanics proposed by physicist Hugh Everett in the 1950s, posits that an occurrence of every quantum event, all potential outcomes manifest in separate, parallel universes. This theory suggests that reality branches into an array of parallel worlds with every possible outcome from a quantum event. In this framework, the wave function, instead of collapsing to one outcome, encompasses all potential results, each exiting in its distinct universe, collectively forming a multiverse of countless parallel realities. Despite offering a resolution to the quantum measurement problem, the many worlds theory is just one of the many various interpretations of quantum mechanics. And this is another one that's really interesting in my opinion, because it's saying that every single different decision we all make creates a different world. So if I decide to say a different word, then there'll be a whole another world created where I said another word. Or if you make one action, then a whole nother world will have worlds and hundreds of thousands of worlds that do make you do another action. So technically there's infinite different worlds where everyone's doing different actions and stuff like that. Pretty complicated, but another really interesting entry. Zuma disappearance. The Zuma mission was a classified satellite mission launched by SpaceX for the United States government in January 2018. However, significant details about the mission, such as its purpose and the agency that oversaw it, remains classified. Reports emerged suggesting that the Zuma satellite failed to reach its intended orbit, leading to speculation about its disappearance or failure in space. The satellite was launched aboard a Falcon 9 rocket and appeared to have been successfully deployed. However, various news sources reported that the satellite might not have functioned as intended, with conflicting claims about whether the mission was unsuccessful due to the fault in the satellite itself or the result of a failure in the deployment process. Official details about the fate of the Zuma mission are scarce due to the classified nature of this operation, and the lack of public information and the secrecy surrounding the mission's purpose has led to tons of conspiracies surrounding the fate of the satellite. Alright, now on to Tier 8, starting off with the starquakes. Known as stellar quakes are seismic activities occurring within stars that mirror the geological phenomena or earthquakes that are familiar on Earth. These events are typically caused by stress and movement of matter within the stellar interior, leading to the generation of seismic waves that propagate through the star's structure. Their occurrence is often linked to factors such as magnetic activity, convective processes, and interactions within various layers of the stars. For instance, in a highly dense celestial body like neutron stars or pulsars, starquakes may be induced by intense gravitational forces and rapid rotation. Observantly, starquakes are detected by studying fluctuations in a star's brightness or surface oscillations. Final parsec problem represents a challenge within astrophysics, focusing on the gravitational interaction and merging process of supermassive black holes, particularly at the centers of galaxies. These black holes, often millions to billions of times the mass of the Sun, are expected to merge during galactic mergers. However, as they approach the last parsec, about 3.26 light years away from each other, a significant obstacle arises. The dynamics of a three-body system involving two black holes and the surrounding stars poses difficulties in their gravitational interaction. At this critical distance, the black holes may stall or expel one another due to the gravitational interactions, hindering their ultimate merger. Astrophysics are actively studying these systems to resolve this problem, exploring the role of nearby stars and surrounding matter in either facilitating or impeding the merging process. Soyuz TMA-11 superstition. The Soyuz TMA-11 spacecraft mission, flown by Roscosmos, attracted superstitions due to several curious incidents associated with the mission's number and crew choices. The number 11 has an ominous reputation in Russian space history due to the past Soyuz missions with the same number encountering difficulties, including fatalities. Adding to these superstitions, the mission was launched on October 10, 2007, a date that was numerically reduced to the number 11th, further fueling apprehensions. Despite its superstitious associations, the mission carried Russian cosmonaut Yuri Makolenchenko, American astronaut Peggy Whitson, and Shaikh Muzaffar Suqar, the first Malaysian astronaut, in his attempt to possibly counteract their perceived ill omens. Nonetheless, the Soyuz TMA-11 mission proved successful, achieving its objectives and demonstrated the capability of the crew in the spacecraft, and the superstition obviously didn't mean anything because they ended up succeeding. Moons with rings. In our solar system, the presence of moons with their own ring systems is relatively uncommon, but not entirely absent. Saturn's moon, Rhea, is the most recognized moon confirmed to have a faint ring system. Discovered through observations made through the Cassini spacecraft mission, Rhea's rings, although faint, are a notable example of a moon with its own ring structure. However, these rings are less conspicuous than Saturn's prominent ring system, which are really easy to see. Beyond Rhea, there's ongoing speculation and observations hinting at the potential for other moons in our solar system to possess rings or ring-like structures. Moons of planets like Uranus and Jupiter have been subjects of scientific discussions suggesting the presence of a ring system. However, these observations are yet to be confirmed or extensively studied, leaving room for further exploration and investigation. The end of greatness. The concept of the end of greatness in the context of outer space could refer to a few different philosophical concepts. One potential interpretation might involve the idea that in the vast expanse of the universe, there might not be an ultimate or singular endpoint of greatness or significance. In the cosmic scale, the concept of the great greatness might reflect the notion that in an infinite or near infinite universe, there might not be a specific or ultimate reference point that stands as the pinnacle of greatness or significance. It suggests that in the cosmos where countless galaxies, stars, and celestial phenomena exist, the idea of a single, ultimate, or supreme entity might lose its meaning. This concept challenges the human-centric view of greatness or significance, acknowledging the enormity and diversity of the cosmos. While no single entity may hold absolute eminence, this concept might also touch upon the idea that our understanding of the universe continues to expand, and we really don't know much about space at all. You might be a Boltzmann brain. The idea of being a Boltzmann brain is a concept from theoretical physics and cosmology that addresses the potential existence of spontaneously appearing, self-aware entities in the universe, seemingly out of statistical fluctuations rather than through traditional evolutionary processes. The concept is named after the physicist Ludwig Boltzmann and is based off a hypothesis that in an infinite universe or vastly extended universe, it's possible for complex systems or conscious entities to arise temporarily due to random fluctuations in the cosmic structure. According to this theory, it's theoretically more likely for a brief, self-aware entity like a brain to spontaneously emerge out of chaos rather than being a sustained and complex evolution required for life as we traditionally understand it. A Boltzmann brain scenario proposes that in an infinitely expanding and fluctuating universe, there could be rare occurrences where conscious entities or brains might form by just sheer chance, without the need for intricate biological or evolutionary processes typically required for life as we know it. However, this concept is highly controversial and raises significant questions and debates about the nature of existence and the stability of the universe and the reliability of our perceptions and reality, and if brains can just come out of nowhere. Merging of fundamental forces. The merging of a fundamental force represents a fundamental pursuit in physics, aiming to unify the distinct forces that govern the behavior of the universe into a single comprehensive framework. These forces, which are gravity, electromagnetism, and strong and weak nuclear forces, are presently described by separate theories due to their different behaviors at various scales. Physicists aspire to establish a grand unified theory or a theory of everything that would encapsulate all known forces under a single coherent framework. However, merging these forces poses significant challenges as their behaviors diverge notably at varying energy scales, particularly at very high energies or small distances, making their unification complex. Despite notable progress in areas such as electroweak theory and various string theories, achieving a complete and harmonized theory encompasses all fundamental forces remains an ongoing endeavor. And so basically, it's really hard to just get a bunch of knowledge and put it all into one kind of more digestible version. And so who knows, maybe in the future there will be some great scientists and geniuses that are able to just put all of this knowledge into one more digestible and understandable framework. CMB is quantum fluctuations. The cosmic microwave background radiation pervasive throughout the universe is a residual glow from the early stages of the universe and holds vital information about its history. It is intricately connected to quantum fluctuation that occurred in the universe's premortal phase. Quantum fluctuations, minute and temporary energy variations inherent in quantum physics, played a crucial role in the universe's initial conditions. During a phase of rapid expansion known as inflation, these fluctuations were amplified and stretched across vast scales, serving as the seeds for irregularities observed in the CMB. By analyzing temperature fluctuations within the CMB as detected by instruments like the Planck Observatory, and basically they're just trying to find where the universe even came from, or if we can know more about the universe's infancy. And now onto the second to last tier, tier 9. If you're still watching this far into the video, consider subscribing because you're already this far, and like if you haven't already. But like I said, tier 9 and the second to last tier, and the first entry being quantum immortality, with in quotations, do not research, but we research what's not supposed to be researched on this channel. So let's get it. Quantum immortality is a thought experiment within the realm of quantum mechanics and the many worlds interpretation. It postulates that a conscious observer might subjectively experience a form of immortality due to the branching nature of the multiverse. According to the many worlds hypotheses, each quantum event results in the universe branching out into different multiple entities, with each potential outcome occurring in a separate branch. In the context of quantum immortality, the theory suggests that a conscious observer would only be aware of the branches in which they continue to survive. Therefore, despite the potential of facing life-threatening situations or scenarios with uncertain outcomes, the observer would subjectively experience a continuous sequence of survival, perceiving only the branches where they would remain alive. Holographic universe. The holographic universe theory possesses a compelling idea that challenges traditional perceptions of space, time, and information. It suggests that information described in a three-dimensional space could potentially be entirely encoded on a two-dimensional surface, akin to how a hologram captures a three-dimensional image on a flat surface and looks 3D but it's really 2D, originating from investigations into the string theory, black hole physics, and entropy. This theory proposes that we might perceive as a three-dimensional universe might actually emerge from information stored on a lower dimensional boundary. If validated, this principle could fundamentally reshape our understanding of space, time, and matter, offering new insights into the nature of gravity, quantum physics, and the underlying structure of the cosmos. Only one electron exists. This concept proposing that only one electron exists is an intriguing hypothesis introduced by physicist John Wheeler. It suggests that myriad electrons observed in the universe could potentially be manifestations of a single electron moving back and forth through time. This theoretical proposal was intended to illustrate the intricate nature of electron behavior within the framework of quantum mechanics. It's not a literal claim of the physical existence of a sole electron, but rather a thought experience designed to accentuate the challenges in discerning individual particles at the quantum level, and really complex stuff that I can't even wrap my head around, but I'm trying to just explain it the best I can, and I hope I am doing a decent job at explaining this. But a lot of these theories and stuff like that are really complex, and so they're really hard to just kind of get on a flat level and explain, so hopefully I'm doing a good enough job. Astronaut Edgar Mitchell believes in UFOs. Astronaut Edgar Mitchell, known for his historic Apollo 14 moonwalk, openly expressed his belief in the existence of unidentified flying objects, otherwise known commonly as UFOs, and their potential visitation to Earth. Post his astronaut career, Mitchell became an advocate for UFO research, suggesting that governments were withholding evidence supporting the idea of a UFO visitation. He founded the Institute of Noetic Sciences, focusing on consciousness exploration and human potential, which also delved into unconventional phenomena. While Mitchell's beliefs on UFOs were personally held, they were not widely endorsed within the scientific community and remained a topic of controversy, standing outside the mainstream scientific discourse. But don't you think it's a little bit weird that an astronaut started doing a bunch of UFO research when he came back to Earth? Who knows? But it's just a theory and conspiracy. False vacuum. The false vacuum is a concept within particle physics and cosmology that suggests the universe might not be in the most stable state. It pertains to the idea that the universe could exist in a state that seems stable but might not be the most stable state it could occupy. This concept is central to the understanding of vacuum states in quantum field theory. It proposes that the universe might be in the miscible state akin to a ball sitting in the shallow depression rather than at the bottom of a deeper energy well. If the universe were in a false vacuum state, a transition to a more stable state could lead to significant alterations in the fundamental properties of the universe, potentially impacting space-time and the laws of physics as a whole. Everything is a spine. The concept of everything is a spine introduces a hypothetical framework where every physical object is equipped with a unique identification and extensive metadata, forming a network of interconnected entities. Coined by science fiction writer Bruce Sterling, this speculative idea envisions a world where each object, from its creation to usage and eventual disposal, is tagged with detailed information. These spines would be interconnected, exchanging real-time data and allowing a comprehensive understanding of an object's history, purpose, and status. The solar system is a zoo. The idea that the solar system might function as a zoo within the context of potential extraterrestrial life is a speculative hypothesis at best. This concept suggests that advanced alien civilizations, if they even exist, might be observing Earth from a zoo sort of perspective, similar to humans observing animals in a zoo. Proponents of this notion propose that these hypothetical extraterrestrial entities might be refraining from direct contact or interference to avoid disrupting humanity's development. Now, onto the final tier of the space iceberg. tier 10. So let's get into it. The universe might be a fundamental particle. The proposition that the universe could be a fundamental particle emerges from certain quantum cosmological theories, notably within the framework of holistic quantum cosmology. This speculative concept proposes that the entirety of the universe, including its matter, energy, and space-time, might be seen as a fundamental particle with an unknown broader context. It suggests a metaphorical comparison, likening the potential quantum nature and the behaviors of the universe to those observed in particles within quantum physics. The axis of evil refers to an intriguing anomaly observed within the cosmic microwave background. Once again, we're going back to the cosmic microwave background, so it's pretty important. But anyways, the residual radiation from the entire universe. This anomaly possesses to the unexpected alignment or pattern in the distribution of hot and cold spots in the cosmic microwave background. Deviating from the assumed isotropy of the universe, this surprising alignment, discovered in the early 2000s, has raised questions and debates within the scientific community about its significance. Some scientists argue that it might be a statistical fluke or an outcome of seismic errors, while others suggest it could indicate unknown cosmological phenomena. Unraveling the true nature and significance of this alignment is the ongoing subject of investigation and debate. Reality is just information. Understanding reality as fundamentally rooted in information is a concept emerging from the intersections of theoretical physics, informational theory, and quantum mechanics. At its core, this idea proposes that the essence of the universe in all its aspects can be comprehended and described through the lens of information, akin to how data is processed and encoded. One facet of this notion is the holographic principle, suggesting that the totality of information about a volume of space might be encoded on a lower dimensional surface, hinting that our three-dimensional reality could be just a hologram projected from a two-dimensional source. Quantum mechanics, with its probabilistic nature and the role of observation, adds another layer to this concept by imitating in the properties and behavior of particles might be fundamental information. And so basically, this one is just saying that reality is just information that is kind of put there. I don't know, this is high-level stuff, so I'm trying to do my best to explain this, but once again, I'm not any sort of scientist or physicist. Living stellar objects. The idea of living stellar objects presents a metaphorical concept suggesting that certain celestial bodies like planets, particularly stars, might exhibit processes or behaviors that bear resemblance to characteristics of life observed on Earth. This metaphorical analogy often stems from attempts to describe the complex and intricate phenomena associated with stars using terms typically associated with living organisms, such as growth, cycle, and the notion of birth and death. However, it's crucial to emphasize that this term living is used more figurative than literal, used to draw conceptual parallels rather than suggesting actual life existing on stars or that stars actually are life. So it just kind of draws a parallel between the two, and it's not saying stars or planets actually have living ideas and stuff like that like humans, but they just follow the similar characteristics. Another universe seen in the CMB, once again going back to the cosmic microwave background, and this speculation about detecting another universe with and within the cosmic microwave background arises from the anomalies observed in the CMB data. These irregularities have led to conjecture about the potential existence of alternate universes or realms beyond our observable universe. These anomalies in the CMB have fueled discussions about multiverse theories, suggesting the possibility of multiple universes, each with distinct physical laws or conditions. However, the idea of identifying evidence of another universe within this BMD remains highly speculative and subject to many debate within the scientific community. Backwards time travel is possible inside a black hole. This theoretical concept of potential backwards time travel inside a black hole emerges from mathematical solutions within the realm of general relativity. These solutions suggest scenarios, particularly within the context of rotating black holes, where extreme space-time curvature might permeate closed time-like curves or paths that loop back on themselves, theoretically enabling backwards time travel. However, this concept remains deeply theoretical, and no one really knows how it would even work, but it is saying that black holes might be a possibility of time travel back to the future or to the past, which is a really cool theory. All energy can be represented as a single wave. The concept of encapsulating all energy forms within a single wave stems from the quest for a unified field theory in physics. This idea postulates that, in a fundamental level, all energy and interactions in the universe might be represented by a single underlying wave or field. Such as a theory would aim to unify the diverse fundamental forces and particles observed in nature, integrating gravity, electromagnetism, and the strong and weak nuclear forces into a coherent framework. This concept aligns with the principles of quantum mechanics, reflecting the wave-particle duality observed in fundamental physics. And that wraps up the iceberg. Just like that, we got the space iceberg done in about almost 2 hours in. So thank you for watching if you are still watching, and it really means the world if you are watching and that you're even watching the video in general. It's crazy the growth we've had in the past month or two, past 3 months have been insane. Gaining so many subscribers and views, and I just am very grateful. Thank you all for watching. It's just crazy. And the next goal being 100,000. So if you're watching, make sure you subscribe if you're not. 100K around the corner, hopefully. And go watch another one of my videos if you want. I may have tons of different icebergs, and I'm sure one will pique your interest. So with the outro out of the way and the entire iceberg done, see you guys next time.